Hello everyone, this is Mohit Jotwani from DataTorrent. I have with me my colleague Mr. Deepak Narkade, and today we welcome you all to this another webinar session where we'll be looking at Hadoop streaming ETL application that will be created from an app template, Kafka Filter HDFS. So we'll be talking more about the DataTorrent project Apex, look at the overview of the architecture as such. So we've got a few more minutes to start the session. So we'll just wait for others to join. I hope we are clearly audible to everyone. Those who could hear us, if you could just raise your hand, that will help us in identifying. And there is a question panel, so as the session continues, please feel free to type in your questions, and throughout the session we'll try and answer these questions while we are going through the session, or we'll take these questions at the end.
I starting my broadcast. Attendance Should I start the broadcast now? I wasn't.
Hello everyone, welcome to another webinar in this series of webinars based on the AppHub templates. My name is Mohit Jotwani. I am part of the product management team at DataTorrent, and I have with me my colleague Mr. Deepak Narkade, who is a senior software engineer and a committer at Apache Apex. So we'll be talking about streaming ETL application that we'll create from an AppHub template, Kafka Filter HDFS. We've got a few minutes left, so we'll just wait for others to join in. I hope we are audible for the entire crowd over there. If you could just raise your hands, those who can hear us, it will just let us know whether our voice is clearly going out. Thank you. So just give us a couple of more minutes. We'll see if more people are joining, and we'll start shortly. There is a questions panel, so as we go through the session, please feel free to post your questions. We'll try and answer as many as possible during the session, or we'll take most of the questions at the end. Well, thank you all for taking our time and being part of this particular webinar. There are other webinars that will be happening in this particular series, so please do look out for other webinars that will be shortly announced. The video and the slide for this particular webinar will be available on YouTube and on SlideShare. So we'll start the session. I guess we have more than enough audience here. Once again, thank you all for taking out time and being part of this webinar. So in today's agenda, we'll be looking at the vision that was looked at DataTorrent, what exactly the people at DataTorrent who founded the organization they thought about the big data ecospace, what needs to be done. So we'll look at that particular part. We'll talk a little bit about Apache Apex. Again, this will be just a brief overview. There are quite a few webinars in the past that we have conducted. You can search for them on YouTube, and there are some exclusive sessions about Apache Apex. Then we look at the concept of app templates, which is part of our enterprise offering. So these are basically Java application packages kind of configured as templates as part of our RTS enterprise offering from DataTorrent, which is powered by Apache Apex. It's also available on our website, datatorrent.com. So we particularly look at one particular app template from Kafka to HDFS with filtering operator as a processing operator in between. Then my colleague Deepak will take you through a live demo of this particular app template and how another operator, what we call as operator, which is like a logical function, a business function that can be added to this particular existing app template, and an application can be created, which is basically run over our platform Apache Apex. And then we look at a little bit about the roadmap, what's going to follow in this particular app template zone. So when we talk about the vision of DataTorrent, so primarily the vision was to productize big data. If we look around the concept of big data, if you look around the ecosystem around big data as such, you won't see many of the entities in this particular ecosystem that are really productized. And when we look at it from a development operations perspective, it's not really operationalized. The offerings that are there in the ecosystem, there are good offerings, but still they have not reached that particular level. So this was one of the main criteria that the DataTorrent team had actually visioned. And then the other part was the total cost of ownership, which not only is restricted to the operational and the maintenance cost of an ongoing application or an ecosystem as such. We also look at the time taken to develop a particular application and the time taken to launch these applications, and obviously then the maintenance cost of these applications. So these were the key criteria when we talk about the total cost of ownership, when we talk about a big data environment. And then when we look at the product, so what kind of product we were envisaging. So this is a particular product which allows people to build their applications rapidly with very simple interfaces. There are some pre-built apps, what we are calling them as app templates. There is a lot of reusable code that is available in our open source repository, and it can be easily debugged. So these are the three criteria if you look at it from a big data development perspective. Then, and obviously from the support side, the DevOps support, the testing part of it, taking it to a production environment and launching these apps as quickly as possible, vis-a-vis comparison to the legacy way of looking at application where you would actually define the requirements, follow a waterfall life cycle, then ultimately design and develop the particular application, which would take a longer period. And then managing and maintaining it would raise your cost like anything with the vendor lock-ins. And ultimately managing and visualizing these particular applications in a day-to-day operational scenario. So these were the key factors that were thought about at DataTorrent, and that's why we brought in this particular project, Apache Apex, in the ecosystem. So when we talk about the next generation big data applications, so we are looking at some of these artifacts. So the variety of sources, the variety of sinks that are available in today's environment. So if you go back the last 10, 15 years, we've seen the changes that have happened in terms of data and in terms of the sources of these data. So, and then from an IoT perspective, the sensor data that is available, different social media unstructured data that is available through various APIs, the likes of Twitter and so forth, a lot of scrape data, data from multiple file system, data from files as such, and so forth. In terms of sinks or data sources as such, so we have moved leaps and bounds from going from RDBMS stores to object-oriented to NoSQL now to message queues like Kafka and file system like HDFS. Now, there is a requirement of low latency for the next generation set of applications. So we are looking for these particular factors in these applications. Then we talk about unbounded and continuous data streams. So when we look at a batch scenario or a batch application, which has been a traditional way of developing these applications, where you actually read the data and stage it at some place, and then ultimately do the processing on this particular stage data, and applying your business logic and ultimately looking at this data on an ad hoc basis. So there is a lot of change in this particular paradigm where people have started looking at unbounded data, continuous data streams. So where the data is available at almost the event time in most of the scenarios, or at as much as real time possible. That's a desired part. So people are looking at applications which can actually support such kind of continuous data streams. And eventually, this is all being looked upon from an in-memory processing, from a windowing concept that is being introduced in a streaming kind of scenario. And obviously having support for stateful operation where we could do some dimension computations, we could apply business rules as well as logic for analytics, looking for patterns, and for applying machine scoring algorithms. So just to give you an example, if you look at this particular slide, the image below, so the browser is basically your client, which is actually providing a lot of data as logs. So let's say a message queue like Kafka. So this is a Kafka client, which is invariably reading these logs. These logs are then decompressed, let's say parsed. You're filtering these logs. You're computing various dimensions based on certain fields that are coming into these logs. And ultimately, you could throw it back to a Kafka queue as such, or to a JDBC store, or to a NoSQL store. It entirely depends upon the business need. So if you look at this particular pipeline, so which is also known as a directed acyclic graph in Apex terminology. So this is the next stage of big data application. So how quickly you can consume this data, so read this data, perform all the computation on this particular data, and then ultimately make it available to the business side so that they can act upon it as fast as possible, in as real time as possible. So where exactly DataTorrent fits into this big data ecosystem? So if you look upon this particular slide, so if you look at the Apex part, Apex is actually a Yarn client. So just to clarify the difference between Apex and Yarn, so Yarn is the scheduling part of Hadoop. So we are native to Hadoop. So any distro such as Mapr or Hortonworks or Cloudera 2.2 plus is what is required by Apex. So Apex can be thought of as a Yarn client application, which basically requests for resources in terms of the memory, in terms of the CPU, from the Yarn scheduling part of Hadoop. Apex itself does not have any scheduling capabilities, so it relies on Yarn for that particular resource scheduling as such. So we can run this on any environment. It has to be, it could be a cloud environment, it could be a physical environment, it could be a virtual environment. And on top of Apex, what we just saw as directed acyclic graph. So these are operators that are available as part of the Apache Malhar library. These are some 300, 400 odd operators where we have all these connectors which would actually read data from different sources, sensor data, social media data, server logs as such, which could be read through message queues like Kafka, through file systems like Amazon S3, through Solace systems, and so forth. They can then be connected via on top of Apex. So these are basically Java application packages that are being built, where these connectors are connected as a directed acyclic graph. So an example would be Kafka client can be connected to, let's say, a CSV parser, then to be connected to a transformation operator, and then ultimately you're doing some dimension computation on it, or running some complex machine scoring algorithm on it, and ultimately writing this particular score to some persistent store like HDFS. On top of that, as part of our RTS offering, which is the enterprise part of the offering from DataTorrent, it also has built-in real-time analytics and visualizations, uh, where we can look at the different metrics of each of these operators, as well as there is a layer which you can monitor and manage your entire application. So this is where, these two particular part, Apex and the operator library Malhar, these are the open source part, and this entire picture is the enterprise offering from DataTorrent. So to look at an overview of the architecture, so if you look at the lowest layer, as I just mentioned, so we basically need a Hadoop 2.2 environment, which basically has yarn into it. So any kind of infrastructure, whether it's on-premise or cloud, any distro or even vanilla Hadoop is fine. On top of it is our core engine, which is Apex, which has got built-in fault tolerance, built-in scalability. So these operators that we saw, you could actually statically partition these operators in the directed acyclic graph, or dynamically partition it. You can actually configure rules. So there are concepts of windowing as well as checkpointing, which ensures that even if your application crashes, we continuously checkpoint the state of these operators, not the data, but the state of these operators, and ultimately commit the state of these operators based on configured windows.
Somebody else said.
I guess there is a request to go back to the previous slide. So probably there's a question over here.
No, I just finished showing a screenshot.
Oh, okay.
Slides will be available.
So I would request that we continue with the session. These slides, as we mentioned, would be available on SlideShare. So if you look at SlideShare tomorrow, all these slides would be available, and the YouTube video will also be available. So coming back to the architecture overview. So we're just talking about the core part of this particular architecture, which is the Apex engine as such. So this project was introduced, it was incubating in mid of 2015, and we became a top level project at the end of April last year. So in a very short time, we went from incubation to a top level project, and it garnered a lot of interest. So there are quite a few contributors, primarily from DataTorrent. We have 60 plus contributors overall, the globe as such, from some prominent organizations. So in terms of the development framework, on top of this particular engine, which provides the built-in fault tolerance, the scalability part, and all the operability challenges that are available in a DevOps environment, which have been taken care of as part of the engine. On top of that exists the Apex Malhar operator library. So here are those 300, 400 connectors, which allow you to read data from different sources, process this data, transform this data, and you could actually integrate it with a machine learning library such as H2 or Dato, or you could actually write some SQL queries where we have integrated with the likes of Apache Calcite, or you could actually introduce your own custom operator as part of this library as such. There are also things like high-level API where you could actually just take this API and construct an application. There is support for batch applications. There are integration with the likes of Apache Calcite and Apache Samoa. In the roadmap, we are going ahead with providing a high-level API for Python. So Python developers would be able to write an application very easily. And there is support being considered for Mesos in the future. So in terms of scheduling, you could use Yarn as well as Mesos at a later stage. On top of this, what we basically will talk about in this webinar are these application templates. So from a lot of interaction with our customers, with some of our prospects, and internally, what we've realized is these are some of the general applications or other application templates that people generally look for. So reading data from Kafka and writing to HDFS, or from JDBC to Kafka, JDBC to JDBC, so forth. So we came up with this concept of an app where these templates can be easily provided for people who can download them and then play with it and customize it accordingly and create an application out of it. So these could be sync applications, these could be backup applications, or this could be just normal streaming ETL pipelines that could be created by any development community. So these are all written in Java. Apex itself is written in Java. There is a support for Scala as well. As a part of the DataTorrent enterprise offering, it's the top layer which constitutes of a management and monitoring console. So you can actually manage your applications, look at what is exactly happening with all these applications. There's a real-time data visualization part where you have all these widgets which capture all the metrics from these operators. There is an interface, there's a canvas where actually these operators can be dragged and dropped. An entire assembly of the application can be created. There are certain solutions that have been provided by DataTorrent, like ingestion solutions, which can be easily downloaded and used by people in the ecosystem. So this is the overall architecture from DataTorrent. So Apex and Apex Malhar are the main constituents of this architecture, and we have now introduced these application templates. So coming to these app templates, so what exactly made us, provide these app templates? So based on our continuous involvement with the community, with the people in the industry, so we saw some of these normal patterns. So in terms of, let's say, machine scoring or transformation of data or enrichment of data or synchronization of data, we were seeing mostly these sources, these kind of processing operators, and ultimately these things that you see. So, for example, for Kafka, data being read and the modeling being done on an H2O library. Ultimately, we integrated with H2O. One of our clients actually did that. And basically did the entire scoring using H2 and ultimately wrote it to an HDFS file system, and so forth. So all these operators are available as part of the Malhar library. Some of them are custom, which were developed by our customers. So these kind of regular patterns were visible in the ecosystem. So we thought it's a good idea to actually make them available for the entire community, for the entire world as well, to look at these particular app templates on top of Apache Apex. So you could actually download these app templates from our AppHub and actually build your own application. All that is required that these particular operators be configured, the properties of these operators be configured, and you can just launch the application easily. So basically, the AppHub is nothing but an app template repository. As of now, all these app templates have been provided by DataTorrent as such. The future of this AppHub is you'll be able to create your own app templates or application offering and actually upload it in this particular repository. So it's just a central repository for all these applications. They have been tested thoroughly by our team at DataTorrent. It can be easily accessed. All the metrics, the management, and the monitoring part of it is available via DataTorrent RTS's console as such. These AppHub templates can also be downloaded from our website, datatorrent.com. So either you can download the latest version of the DataTorrent RTS from our website, or you could download these app templates directly from our website. So you have both the options. And we intend to provide further version updates via our console in RTS. So you can continuously look for the next version of our RTS to see further updates to the existing app templates. So what are the advantages of having these app templates? So as I mentioned, when we were talking about the vision of DataTorrent, so the idea is, as the key operability challenges have been taken care of in our core engine, Apex. So our enterprise offering is powered by Apex. So the other key part is to actually provide these application packages, kind of pre-built application packages, which just need to be configured, and you can quickly just download it, configure the parameters, or make some custom changes to it, which is not difficult as such, and easily launch it on a production environment or a pre-production environment. You can easily add any business logic by adding your own custom operators, and Java is a very easy language that people are more comfortable with. So that was one of the key factors. Then, as we talked about the time to market and the total cost of ownership, it reduces your time to market drastically. So imagine the days when one would actually take months to build such kind of application. It would take just a couple of days, or if somebody is trying hard, it might take just a week to just get this application going. And obviously, since it is native to Hadoop, the costs are reduced massively. And these are reusable operators, so you don't have to continuously keep on writing the code again and again. These can be extended and customized as per your need. In terms of the data visualization, in terms of the metrics about the particular applications, already the built-in real-time visualization widgets are available as part of the RTS. So as a user of this particular project, you don't have to do much over there. So in short, you just have to connect these operators and they are good to go into a production environment. So I will now hand it over to my colleague Deepak, who will take you through this particular app template, Kafka to filter to HDFS, and see how we can build a streaming ETL pipeline from this particular app template.
Yeah, thanks Mohit for in the first part. So before we start up with the application, I'll just brief you about the Kafka so that we understand the application well. So as we know that Kafka is a distributed messaging system. So and it has a dynamic partitioning capability. And so the main key aspect is here the basic terminology what we use in our application. Is that the topic and consumer. So basically, our application is nothing but a one of the consumer of Kafka, and the topic is nothing but a feed name you can think of. And so as in we produce the data, we try our consumer will try to consume the data. So basically, our input operator would be Kafka, and it is basically a pull mechanism. So we try to pull the data from Kafka thing. So before we go to a live demo, I'll just share the link so that you can download the code also and have hands-on on the code, and you can modify and enrich the existing DAG and have your application run. So these are the links and sources. So we'll share this slides also. So I'll just, as Mohit mentioned, that we have a DAG. So for this template application, we have a DAG which has kind of 4 to 5 operators in pipeline. So what we will do is that we'll pull the data from Kafka. So whose Kafka input is an operator which will pull the data from Kafka, which is the input adapter basically. And then we'll pass on that data with CSV parser. We'll pass the data and we'll move the data to filter operator. So filter is nothing but a condition given to us a particular record. So according to that condition, it will try to filter the records coming from the CSV parser. So for example, let's say there's a tuple. So a tuple is nothing but a record or a unit of a data. So for this case, it would be a a POJO object. So it will consider that it has a amount and some personal info. So filter condition would be that we will have amount greater than some value. We want to filter that tuples. So we'll have a filter operator and we'll provide a filter condition to it. And it will pass on that information. So only the operators would be filtered according to the condition, and formatter will just format it into some format. So we specify the schema what should be the formatter, and we'll dump it to the HDFS location. So file output is nothing but the HDFS output operator. So this is a DAG, what logical DAG we'll look at. So I'll just move to the live demo. So this is our DataTorrent console. So in Community Edition, you will have some trimmed down version, and in RTS, you will have visualization and things in that. So you'll see a AppHub tab here. So you'll have list of tab templates here. So you can see all the packages in AppHub here. So today we'll just look at the HDFS Kafka to HDFS filter app. So I'm trying to import that application to our console. Sorry, there was some technical disturbance. So when you so you'll see this page which when we try to import, so you'll have some description here, and I'll just try to launch this app. So before launching, so we have some certain options and properties to be filled up. So with this app template, we have two configuration files. One is the cluster memory config, and one is the sandbox config. So basically, if you have a physical cluster which is high-end machine, so you can you can use cluster memory config, so whose parameters will be pre-configured with high resource usage. So let's say partitioning values and memory config. If you want to run it into some standalone machine, standalone Hadoop cluster or a local machine, so you can try out sandbox memory config, which consists of a minimum resources requirements. So right now I'm working on some physical clusters, so I'll select cluster memory config. And so when you click on specify custom properties, so these are the properties we can change it runtime. So let's say your input is Kafka input. So these are nothing but clusters are nothing but the broker list. So right now I have broker of node 0 dot. So this is my broker, which is pre-configured with 3 partitions. So I have created 3 partitions with topic called transactions. So you can specify the topic name here. And initial offset, earliest is nothing but the offset which we try to get from Kafka. So let's say I want latest data, always which is latest in the Kafka. So we can change the initial offset to latest thing. So you will always get the latest data. And if now I have specified earliest, so what this will do is every time you launch a app, it will try to pull it from the initial 0th offset. And as I mentioned, the filter operator here. So filter condition I have provided. This is, let's say your amount is greater than equal to 2000. So if it will scan the tuples, and it will check that if the amount is greater than 2000 or 20,000, it will move on the tuple to further operator. And these are nothing. File output is nothing but the HDFS operator, output operator. So all the data records would be dumped on this particular location. So file path is nothing but the directory location on your HDFS, and output file name is nothing but where you want to write the data, the file name. So for now I'll change it to, let's say, webinar. Okay. So these are the some pre-properties, and some properties are in cluster memory config, which are related to memory and resources configuration. So I'll just try to launch this app. So I have Kafka running in background on cluster with partition of 3, and topic name is transactions. So as you can see on the right side that it says that the application is launched successfully. So you see this consoles, and you'll see that the state is now running. So it was accepted that it was trying to allocate the containers for the existing operators. So now you can see that it has started pulling the data from Kafka. You can see emitted per second and total processed tuples here. So now this operator is Kafka input operator is trying to pull the data from Kafka as the offset is earliest offset. And this is the logical DAG. Here you can see, and I have selected what are the total processed records and total emitted. As you can see, there are only few are processed from the filter. So the filter operator has acted on, and according to condition, it has filtered it to, and it has sent the records to formatter. And I'll just show you the physical DAG view first, and then we'll go to physical DAG. So in physical DAG view, you can see the logical plan was simple plain DAG. In physical DAG, you can see the Kafka input operator is a partition in three physical partitions. So as I have specified Kafka input as 3 partitions, so our operator in the Kafka is written in such a way that it will understand the Kafka partitions and it will act according to the Kafka partition. So if you specify, if you have created the Kafka partition topic with 4 or 5 partitions, so Kafka input, you will see that it will automatically create 4 to 5 one-to-one mapping of the partition thing. So it is kind of dynamic. So when we change the Kafka partitions, you'll see effect. You don't need to change anything. So it will directly detect that there is a change in dynamic in partition. So as you can see, this is a Kafka unifier. So this is put by the platform so that our application need not worry about the aggregating the what you said, the tuples. So platform inserts a unifier operator which unifies all the data coming from the all partitions, and it will pass on to the further operators. So this is taken care by platform. In physical tab, I'll just show. So you can see this. There are 3 Kafka partitions allocated on different containers. Yeah. So and there are some metrics here. So you can see the allocated memory, free memory, number of operators, and containers here. And if you want to, let's say, debug any container, you just click on it and you can go to logs and check gt logs. You can get the live logs and you can debug your applications easily if you want. So, and visualization part, you can get it in RTS version. So community edition does not have DT manage and visualization. Yeah, so, and there is one thing that we can, if we know that if both operators are working very close to things and we want to optimize the performance, so you can set the locality of the operators also. So let's say if I want two operators who are one-to-one mapping, so what I can do is I can specify the locality of both the operators in one single container or in a single thread, so that the serialization deserialization is not required in that case. So the performance would uh, be a major factor there. If you so we can set the locality. Right now it is automatic locality. So you can just showing logical tab. So as you can see here, locality now it is automatic here. So you can specify the locality as container locality or thread local or node local also, or within a rack also. So I'll just show you the. So as I mentioned that we have uh, copied the or we have processed the file and outputted to an output operator, which is file output, which outputs into HDFS directory. So I'll just show that. So in HDFS path. So you can see that this file has been created, and just cat it. So you can see the records which are coming from Kafka is dumped into the HDFS what do you say, HDFS file system. So I'll just show you the code here. So as I mentioned, I'll just show you the cluster config and memory config. So you can specify so we can have a custom schema. So if you for formatter we have for example we have specified this schema in JSON format. So as I mentioned, our POJO is account number, name, and amount. So you can specify any schema, so and you have to specify the class name here for the same schema, so that our operators understand the a custom POJO thing. So POJO event is nothing but you can say a simple plain POJO where it will consist of account number, name, and amount. Yeah, so this is the application which is Kafka to HDFS filter application. So it is very simple to write an application, streaming application using Apex platform. So you just have to implement a populate tag method and inherit the streaming application. And so I just so these are just 8 to 7 lines of code you have to write. So this is so as we are seeing that Kafka, CSV parser, filter, and HDFS. So these are operators are created here. You can see this first 4 lines are just operators created, and we are just linking them so that we form a stream. So Kafka input is Kafka output is given to an CSV input, and CSV output is given to filter, and so on and so. And you will find that finally formatter output is given there file input. So basically, while writing an application, you just need to what do you say declare or use the existing operators from Mala, or you can have your custom operator too, or custom logic, which is built-in operator, and you have to join them using asterisk method. So it is nothing but you're creating a stream or connecting the both operators with a stream. So let's say we want to have some transform operation within before the HDFS formatter. So what we can do is we can just we can just add a transform operator. What it will do is, and it will have an unmap, it will convert every name to an uppercase value. And this is a very simple transformation. You can have your custom logic and build in it. So what it will do, it will have your name in uppercase, the output. So what we have to do is, I'll just comment out this string so that I want to add the operator after filter. So just I've just added it before formatter. So I've just commented the filter throughput formatter. So after filter, you give the record to a transform operator, and transform will pass the tuple, and it will convert the name into uppercase value and um, give it to formatter. So this is very basic logic. You can have your custom logic within, so that this is the way you can easily insert any business logic or in between any operators. Yeah, I think I'm done with the demo. I'll just move on to the presentation.
Thank you, Deepak, for that fantastic session. We'll just take a moment, and if there are any questions with respect to this particular demo, if there are any queries, please feel free to post it on the question panel. So with respect to the roadmap about the app template, we are planning to add visualization. So there will be some default widgets that you could see where some metrics can be published for a particular app template. There are quite a few apps that would have a schema enablement, so you could actually define the data definition, or rather the data schema, and attach it and associate it with the entire application. That's already available, but the app templates that we will provide will now have some app templates which have schema enabled. We're also looking at cloud integration, so some of these app templates which are already there on the hub and newer ones that will be coming, could actually download them and deploy it in an Amazon EMR or Microsoft Azure environment. These are some of the upcoming app templates. So you could see Kinesis to S3, Kinesis to Redshift, Kafka ETL pipeline with JSON, and there are other parsers as well, like Avro and Parquet, and other processing operators like dimension computation that will get added into this particular app template, AppHub as such. So in short, the whole idea over here is, as we talked about DataTorrent's vision. So the key challenges that are faced from a development operations environment, where there are challenges as to how to scale the particular application when your volume and the variety of the data and different new sources get added into your ecosystem as such. And there is quite a fair bit of computation you still have to do from a business perspective. So you have to apply rules, you have to apply some complex algorithms for which you can create your own operators as such, as Deepak had shown, and create this entire application package and deploy it natively on Hadoop, and where you can scale in or scale out the application based on at the rate at which the data is available. So be it a continuous streaming application on unbounded data, or if you want to run a batch application on some bounded data, so you could actually configure it accordingly. So from our perspective, we look at it as a streaming application. So we look at batch, for example, also as part of the streaming application. It's just a paradigm shift, but it is scalable, it is easily operable, it takes care of all your entire costs. When we talk about cost in terms of the time taken to develop these apps, as you just saw how easy it was, the time taken to launch these applications, to customize these applications, and ultimately maintain these applications. So this is a starting point. for anybody who would like to try this out, you could actually go to these AppHub and try out some of these app templates. We would really welcome that. So if there are any questions, we would like to take any questions now.
There is a question like how DataTorrent is integrated with Azure HD Insight and Kafka cluster.
So from HD Insight, so in the past we have done an exercise with them where they tried out Apex as part of an integrated solution. So that's how we provided this particular solution to them. As of now, there isn't any off-the-shelf integration available. However, it can be easily deployed on an Azure environment. So we have done this exercise with Microsoft. So this has already been integrated in the past. So if there is any requirement for HD Insight for Azure, we can definitely connect and talk about it offline. This Apex has already been tried in the past. So streaming applications can easily be created on Azure. There is another question I saw was on the schema to be read from certain. There's a question, do we include any Salesforce integration? So as part of our roadmap, we'll soon be having an operator which will easily integrate with Salesforce. And these applications can be easily deployed. We've tried it out on Amazon AWS on the EMR side. So these applications are deployable on EMR as such. So you'll be seeing more app templates like Kinesis to S3, Kinesis to Redshift, which can easily be deployed on EMR.
There is one question like can all of the implementations using Apex or DataTorrent be done on premise? That means he doesn't want to put his data on cloud.
Oh, absolutely. So as we mentioned, so the question is, can the entire setup, which includes our Apex engine, the application on top of Apex, this entire pipeline or the directed acyclic graph, can this be deployed on premise? And the answer to that is yes. All that we request for is a Hadoop 2.2 cluster. It could be any distro that you are comfortable with. It could be Cloudera or Hortonworks or Mapr or even vanilla Hadoop from the ecosystem is absolutely fine. So you could create your cluster and download Apex or DataTorrent RTS and deploy it on this particular cluster. There is a lot of documentation on our website as well as on the Apache Apex site as well. And then you can deploy this entire application, whatever is your custom application on that particular cluster in your premise. So for Apex, there is no hardcore requirement that it has to be on premise or on cloud. It's entirely up to the user's preference. It can be deployed on premise or it can be deployed on the cloud.
So also there is one question like what is the minimum or less latency which you can expect with Apex? Like he has an application which takes 15 milliseconds of latency. So could it be reduced using Apache Apex, or it depends upon some excluding the hardware limitations?
So there is an exercise which was conducted by our customer Capital One. If you search for them on SlideShare, they did an exclusive study on all the possible engines that are available for streaming, where they had a similar requirement, and we brought it down. Ultimately, the end performance that they received was less than 2 milliseconds. So, but it depends on your application and depends on the environment. So, and they were running 3 parallel copies of the same application in that same environment. So they were able to lower it down from I think around 14 milliseconds to around less than 2 milliseconds. And it was a fairly significant load of data that they had. So please do have a look at that particular slide share. It's available on, and the video is also available on YouTube as such. So yes, Apex can allow it to bring it to further optimize it to be brought it down, but it again depends upon your application.
Can you integrate visualization tools like Tableau, Power BI?
Yes, there is. We have a REST API offering, so on a vertical side, so it can easily be integrated with the likes of Tableau. So your data can be written to a store within Tableau as such, or it could be written as a Tableau defined format, which can then easily be viewed on Tableau or a Power BI tool. So there is a question about importing schema. So can you import schema from schema GUI from MATLAB? So in terms of schema, what can be done is you can define your schema very easily using our RTS offering. In the roadmap, we are in a process to actually import schema from different sources as such. So down the line, 6 months, we will have this particular feature as part of the RTS offering. There's another question, can we connect Apex source on a social media like Twitter and Facebook? The answer to that is yes. You can usually have some connectors which can read data from a Twitter API like a Firehose API. If you have access to any other streaming API of theirs, you can just easily write a connector and just apply it to your pipeline. So imagine in terms of in place of Kafka, let's say you're reading your data from a Twitter REST API. So, or you have even got operators which are socket based, so both are supported that way.
Integrate with Apex with Kafka and Storm.
So as we saw in terms of integration with Kafka, we easily have these Kafka input and output operators. So you could think of it as Kafka client, which is actually pulling data from a Kafka topic as such. So once you've set up your Kafka cluster, your Zookeeper is in place. So basically, this is pulling data from Kafka. Storm is like similar to Apex. So there are similarities between the two engines as such. So if the question is to integrate with Storm, it's not really a question of integration with Storm as such, but yes, we could consume data from probably an application that is being written on Storm as such. So you could actually run the same application on Apex with Kafka as your consumer.
What are the skill sets required by a person to implement DataTorrent's product or Apache Apex?
So the basic skill set that we require is proficiency in the Java programming language. Although we do have support in Scala, but the entire engine mostly is written in Java, and so are the operators. So if you have Java skill sets, and not up to that level as well, if you understand distributed programming and have Java skill sets, you can easily just write an application in no time. And as part of the roadmap, we will also be coming up with a Python API. We already have a high-level API which is currently in Java. So if you are a Python developer, so just wait for another few months or so. In a couple of quarters' time, we would be having an API for Python developers as well. So in short, you just need to have access to a Hadoop cluster. You need to know how to program in the Java programming language. We'll have support for Java 8 as well shortly. And you just can write your application in whatever ID you're comfortable with and deploy it on top of Apex. So I'm sure that there'll be further questions. We'll try and answer as many as possible. If you have more questions, please subscribe to our forums, our dev at Apex, as well as users at Apex. We'll just shortly show you the links. Please feel free to post your questions. We would be very happy if people would be interested in contributing to the project Apex. So these are the resources, these are the links. So you could go and download all kinds of documentation at apex.apache.org. We are on Twitter. We also have these forums, as you can see, on the community and as well as on the DataTorrent site. If anybody is keen on trying out our RTS offering, please do visit on our website, datatorrent.com/download. We have the options of downloading the sandbox if you don't have Hadoop setup on your machine. If you have the cluster, you can download the RTS version directly. It's available for a 90-day period for a trial version. In terms of all other materials with respect to webinars, it will be available on the YouTube, and the slides will be available on slideshare.net. So you can go to YouTube, user DataTorrent, or slideshare.net, DataTorrent at presentations. We also provide a startup accelerator package, wherein the definition of a startup is any entity or organization which is having revenue less than $10 million and funding less than $30 million US dollars. If they are keen on utilizing our particular RTS enterprise license, we provide it free for a calendar year, where there's no binding for the entity, and we would like them to utilize RTS as much as possible. And as I mentioned, we work very closely with the Hadoop ecosystem as such. So we have been utilized with the likes of Cloudera, Hortonworks, and so forth. And we do work very closely with these distros. So please feel free to look into RTS. And with respect to these AppHub templates, please do take a look at datatorrent.com/AppHub. These templates can be downloaded from our website, or if you have already downloaded RTS, it's available as part of the RTS offering. So DataTorrent is growing, and as we grow, we have to hire some fantastic engineers. We have a fantastic team based out of San Jose as well as in India, in Pune. And if anybody is interested in joining DataTorrent, please feel free to post your resumes at jobs@datatorrent.com. And these are some of the profiles that we are looking at. So if you're interested in development or in QA, or if you're interested in leading the community, so we're looking for people who can help us out in that. It's a very exciting time for us. So we are doing pretty well. The project Apex is garnering a lot of traction. In a very short time, we went from incubation to a top level, and the community is growing amazingly. So it's an exciting time at DataTorrent. We would love to hear from you guys. So if anybody is interested, if you know people who would be interested in joining a fast-growing startup, please feel free to ship your CVs, resumes at jobs@datatorrent.com. And once again, thank you all for your time and for your patience. We would really welcome your participation in the next set of webinars, which will happen shortly. So this series will continue. You'll be seeing more from us. You'll be seeing more app templates and further features that we bring out in our RTS offering. So please be hooked on, look for other webinars. The video and the presentation for today's webinar will be available shortly. Thank you all once again. Thank you for your time and thank you for your patience. Have a good day.